The last part of the Python lecture that I want to go through before getting into limits involves the idea of defining your own function. So what we have seen thus far is that we've repeated certain commands. We figured out a way to quickly summarize repeated commands without having to just copy and paste a whole bunch of commands by way of the for loops and while loops. We also looked at how to control execution, that is, to execute certain portions or certain commands based on conditions that hold true about variables or anything else for that matter. One thing that and by the way, we definitely at this point have looked at how to use functions from packages and whatnot. The one thing that we haven't taken a look into is how do we define our own functions? Because as it turns out, when we define our own functions, it helps us simplify our code, especially if we're going to reuse that code over and over and over again. So, for example, suppose that I wanted to define a custom mathematical function. Okay, let's say the Bernoulli distribution. For those of you who are unfamiliar with the Bernoulli distribution, sorry about that. Not very stable at the moment. I'm trying to get this going. There we go. So the Bernoulli distribution, for those of you who don't know what that is, let's see if I can pull up a quick. I don't want to pull up a browser here because it'll slow things down. But basically, you have a probability. Let's say the probability is set equal to 0.4. The Bernoulli distribution is a function where the only inputs allowed are 1 and 0. Everything else that's passed into that function will return a 0. Anything that's 0 or 1, if it's 0, then it's going to basically return 1 minus the probability, which in this example would be, let's say, 0.6. And if the input set equal to 1, it's going to return the probability, which is 0.4. So in this case, the Bernoulli distribution has 2 inputs into the function. The first is the actual x for which we inquire about, whether x is set equal to 0 or 1. And then we have the probability, p, which is equal to, which is the probability of some event occurring, but that's not important at the moment. It will be important when we all get to our statistics course. So this is a function that has 2 parameters. Now, the way that we basically can define our own function is we use the DEF for define. We give it the name of the function. Let's just say BER. I always spell Bernoulli wrong, but I think that's it. And what we do is we specify the 2 inputs we would like someone to give to us. So think of it in the reverse sense. When we talked about functions, you had to give the function 2 inputs. In this case, when you're defining a function, you need to define what input someone needs to give you. You assume those variables which you have specified as inputs have been assigned to something, and then you basically work with your commands on those assignments. So for example, we have x comma p. What we then do is follow that with the colon, and as you can imagine, it's going to again shift. So we get a block of commands, which will all be executed when someone calls our function. So in this case, basically what I want to do is get the value, right? And the value we're just going to set equal to 0 for now. what we want to do, remember what we said. We said that if x is anything other than 0 or 1, we're just going to return 0 because it's impossible to get any other value other than 0 or 1 in the case of Bernoulli. So in this case, what we want to do is test if x is equal to 0. But we also want to test if it's equal to 1. In other words, we want to give the value back to whoever called our procedure. We want to give the value of 0 back if it's not equal to 0, or if it's, if it is not equal to 0, and if it is not equal to 1. So actually, we should put not equal. Now, the way we specify and is, as you can imagine, the word and. And there you go. So basically what we're going to do is say if the value of x is not equal to 0 and the value of x is not equal to 1, we're just going to hand back the value of 0. The way we do this is through the command return. Return gives back a value to whoever called the function in the first place. So we're just going to say return 0. Now, we don't need to use an else here technically, because the way that the logical flow of the commands are working here is that if it gets to here, anything below here is not going to execute. So theoretically speaking, we don't need an else. So in this case, what we're going to do is just return the equation for the Bernoulli distribution, which, if you, for those of you who took probability theory, you would know that it is equal to p taken to the x power. Okay, remember exponents are with 2 of those, times, we're going to do 1 minus p taken to the 1 minus x power. And what we want to do is say return value is equal to this. And then we're just going to say return the RET value and pretty much call it a day. So let's see if that function works. Let's run our commands. And now we have defined our function. So let's call that function. We do that by just using the name that we've defined it as, just as we call any other regular function, right? Bernoulli. And what we need to do is pass it 2 inputs. Let's suppose that we do 0, and we get, let's suppose the probability of 0.4. Here we see that it's 0.6, right? And if we plug in the number 1, we should get 0.4, which holds true. If we plug in any other number, we get 0. Which is a good thing. That's what we intended. That means that if statement's working out for us. All right, so let's do one more quick example. Let's suppose that we wanted to define a function that adds 2 numbers together and tests whether or not that the summation is even or odd. So let's create a function that will test if the sum of 2 numbers is even or odd. And we can do that again by using the def command. This says, hey Python, we're going to define our own commands, which we want, our own function, which we want to be able to run, which is that collection of commands we want to run with specific inputs given to it, and then we're going to get an output. But we're going to define that function. So we're going to see, we're going to call that test even. We're going to give it 2 inputs, an x and a y, which are the 2 numbers that the user is going to give to us. So the first thing we're going to do is take the summation of those 2 numbers, x plus y. And then what we're going to do is just see if the sum is divisible by 2. Remember from your basic math class, by definition, a number is considered even if it's divisible by 2. So if, when we take the remainder of 2, if this is equal to 0, it's an even number, in which case we're going to return just the value of true. Otherwise, we're going to return the value of false, because if it's not divisible by 2, it is not an even number, and therefore by definition it is odd. Assuming, of course, it is an integer, which is a test that we should probably have done, but that's okay. Anyway, let's run that. And now let's actually use our function. So we'll do test even, and let's suppose 4 and 3. That's the sum of that is 7. That's an odd, so we should have it return to us false, and it does. Let's call our function again. Notice how we're calling our function. We give it the name of the function, and we provide 2 inputs to it. 1 and 2. This should give us false as well. Okay, what about 30 and 60? Well, not 70, 60, whatever. And that is true. 90 is an even number, right? Divisible by 2, which is 45. So here's the moral of the story. We can define functions by using this DEF mechanism. We clarify what our inputs are, and we then basically assume that inputs have been assigned to some numbers or values, and we work off of that. And that's basically the nuts and bolts of a programming language. I mean, obviously there's more, but this is pretty much all you need to know to get off the ground running, to be able to code solutions from the analyst's perspective. And we will be using this to illustrate the concept of limits in the next lecture.